our golden rules for the op amp, which is that our voltage has to be the same at both of the terminals and that the current has to be 0. So we know that V plus has to equal V minus, and in this, for this op amp, we know what that has to be. What does it have to be? 0. Why?
0.
Because it's going into the...
Okay, there's too many of y'all in here for y'all to like be talking to each other, because you just need to, yeah. All right, okay, so why is it 0?
Because
Because of the virtual ground.
The ground is going into the op amp, yeah, because we got ground right here.
Yes.
And so it's going to be 0, this has to be 0, which means this has to be 0. All right,
Were we talking about voltage?
I was talking about voltage.
Oh, I'm sorry. I thought you were talking about current.
Yeah. Okay, so yeah, I haven't gotten to the current yet. But yes, but the answer to the first question, I, does have to be 0 because it is going into the op amp. Now, does it have to be 0 right here? No.
No.
It just has to be 0 going into the op amp. Okay, so now we had the current I has to be 0. Now we're looking for the output voltage VO. So at this point, I'm not worried about what the questions are. I'm just going to, quote, solve this op amp, and then I'll go back and look at what the questions are asking. I'm going to label this point right here as V. And this is already V out. Now, do I know what V is?
You can calculate it.
No, I know what it is already.
No. Do?
It's 0. Everything that's connected by a conductor has to be at the same voltage. So all of this is at 0 until you get to an element. So V has to be 0. So I can find the current through here by saying V1 minus V over 4 equals, I'll call this I1, equals I1. And V1 is 2 minus 0 over 4, so I1 is 0.5. All right. What is the voltage right here? What's that voltage?
It's 0 as
there.
well.
Also 0.
Also 0. So if I want to find I2,
He still can't
I
hear
would
us.
say I2 equals 3 minus 0 over 8, or 3/8, which is, by the way, y'all have to really keep an eye on me when it comes to things like dividing and multiplying, because I can't do it. 0.375 amps. Okay, so can I answer what IF is now?
Yes.
Yes, what is IF?
I1 plus I2.
I1 plus I2, and that's through KCL, because the current is coming into this node. None of it is going this way, so all of it has to go this way. So IF has to be, better be 0.875, and it is. Okay, so IF is 0.875. Now, can I find, so that was the answer to this part, so 0.875. Can I find the output voltage now?
Yes.
Yes. And the way I would do it is I know the voltage right here, and this is what I'm looking for, and I know the current in between them. So V minus V out over 8 has to equal 0.875. We know V is 0, so minus V out over 8 equals 0.875. Our V out equals negative 7. And that is the same thing I got last time I worked this problem. Okay, questions on this one? Yes.
So you cannot just get the voltage and do Ohm's law for, like, you can't do voltage times 8 ohms. And you can't find that. Wait, no, never mind. I'm sorry. The current times 8 ohms. You can't do that.
The current times 8 ohms.
It would work in this specific case, but, like, can you do that all the time?
Ohm's law is usually a true thing. You just have to remember that what Ohm's law refers to, and this is where people mess up. We say V equals IR, but it's really delta V equals IR. Okay, I can't yell. So it's really delta V equals IR. So when we're talking about V, we're talking about the change in voltage, and it would work in this instance because the voltage on this side is 0. Yeah. So absolutely it would, yeah. But you have to pay attention to if the voltage on this side wasn't 0.
Then you just put that in consideration.
Right, because what you're getting is the change in voltage.
Okay.
Yes.
So the reason we're doing V minus VO instead of VO minus V is because of the direction of the current?
Because of the direction of the current. So this is always the way to do find your voltage or current or whatever it is you're looking for. So in the direction the current is going, the voltage on one side of the resistor minus the voltage on the other side of the resistor over the resistance equals the current. So that's the answer to the question because of the direction of the current.
So if the op amp was flipped and the positive, was that terminal would be positive instead?
In this problem, it doesn't really matter because we didn't use the fact there was V plus or V minus at any point. We just used the fact that the currents were 0, and then we used these voltages right here. So we would have gotten the same answer if we had had plus on top and minus on bottom. Other questions?
Oh, so what's the difference between like the last two questions? Like the current going through it and the current after it?
It looks like they're the same question. Yeah. I wrote it at some point, so who knows what I was thinking.
Oh, yeah, they might be talking about the other 8 ohms.
Oh, yeah, okay, let's talk about the other 8 ohm resistor. Okay, yeah, let's do that. So this one, thank you. I say they, like, yeah, they might be talking about, I wrote the question, so. Yeah, so let's do this I2. We found I2. I2 was 0.375. Other questions? All right, then.